Good evening, sir. Myself, Veda, from the Tribal department. Today, my topic is capacitance gradient in cables in detail. If lambda is charged per unit length, the potential gradient at radius x is given by G equal to lambda by 2 pi Ex volts per meter. For safe and long-term operation, the dielectric strength of the dielectric material should be greater than or equal to the product of the potential gradient and the safety factor. For proper utilization of insulation, the potential gradient should be uniform or constant throughout the thickness of insulation. That is G equal to K by 2 pi E into X equal to constant K in equation 3. In equation 3, since the charge per unit length lambda is constant, the following condition must hold to maintain a constant gradient. Ex equal to constant, equation 4. E alpha 1 by x, equation 5. From equation 5, it can be understood that as we move away from the conductor, for increasing x, the has to decrease to maintain the product Ex constant. This implies that the dielectric must have a relative permittivity that varies with the distance from the conductor surface in order to maintain uniform potential gradient. In practice, two or three dielectric materials typically used for capacitive gradient. Consider a cable with three dielectric materials have permittivities E1 and E2 and E3 positioned at ready R1, R2 and R2 respectively. G1 and G2 and G3 are the respective directive strengths and G1, G2 and G3 are the respective electric stresses. There are two possible purposes of arranging these insulating materials. Same factor of safety for all the dielectric materials, resulting in different working stresses for each materials. Same maximum working stresses across different materials. R1 less than R2 less than equation 10 will hold true E0 G1 greater than E2 G2 greater than E3 G3. This implies that the product of permittivity of material with its dielectric strength should be in the decreasing order as we have go to from the conductor surface. The operating voltage V of the graded cable becomes V equal to G max R into in R1 by R plus R1 into in R2 by R1 plus R2 into in R by R2. Equation 6. The operating voltage of the ungraded cable is given by from equation 16 and 17. It is evident that the operating voltage V of the graded cable is greater than the operating voltage of ungraded cable. This implies that the operating voltage of the cables increases for the same size the cable or for the specified operating voltage. The cable size can be reduces the operating voltage. Maximum working stress is the same across the dielectric materials. Gmax equal to lambda by 2 pi E1 R. E1 R equal to E2 R1 equal to E3 R2. R less than R1 less than R2. The equation 15 will hold true The implies that the material with the highest permittivity is placed closest to the conductor and the one with the lowest permittivity is placed furthest. Practically, the capacitance gradient is not used for the following reasons. Not availability of materials with varying permittivities. The relative permittivity of the insulating material decreases over time due to moisture abstraction. This results in higher maximum potential gradients. Thank you, sir.